Hey guys, we are going to talk about the greatest common factor in factoring by grouping. What is the greatest common factor? The greatest common factor needs to first be described as, well, what is a factor? And the factors are the two things that you multiply together to get a product. So in your example, I have 4 times 6. Those are factors. 4 times 6 equals 24. 4 and 6 are factors of 24. Greatest means the largest, and common means they both have the largest factor in there. So when we talk about finding the greatest common factor, we're talking about finding the largest number that other numbers have it as a factor. And what is factoring? Well, factoring is like the opposite of multiplying. It is considered to be part of the distributive property. And whenever you factor something, this is an example here, and that's what we're going to get to. And some of y'all have already done this, to where you take a trinomial and you factor it down. More or less what you've done is whenever you factor this trinomial, you get two binomials in which you're multiplying together. And in talking about multiplying polynomials, whenever I would multiply these two together, this is the answer that I would get. So in math, you learn how to do things one way, and then we show you how to do them to get back to where you started. So we just covered multiplying polynomials. Now we're going to talk about how to more or less get back to where we started using factoring. Well, the first thing that we need to do is look at the GCF, the greatest common factor. So here's an example. I have the numbers 12, 24. What is the greatest common factor of 12 and 24? Well, with some of these you can see them easily. You can say, oh, well, it's 12 because 12 is a factor of 24. But what you need to do is some of them that you can't see, so you need to be able to understand how to work them out. So with this example, I picked one that you should be able to see. How you work it out, though, is you write out the factors. 1, 2, 3, 4, 6, and 12 are all factors. 1 times 12, 2 times 6, 3 times 4. All of those will give you a product of 12. And then you do the same for 24. 1, 2, 3, 4, 6, 8, 12, 24. Because 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24. Those are all the factors of 24. Well, then I go through and I look for a common term. See, greatest common factor. I look for the common term and the largest common term, the greatest common term. And this is where we get greatest common factor. All of these are factors, and I want to find the greatest common one. Well, they all contain 1, but that's not the greatest because they all contain 2. Again, that's not the greatest. And you keep going through here, and then I run out once I hit 12, so guess what? There's 12 in this one, so that is the greatest common factor of these two numbers, the number 12. What happens whenever I'm not given numbers? I'm given something like y to the 8th power or y to the 10th power. Well, the way you can view that is that you can just write all of those out. Here I have 8y's and here I have 10y's. Well, I'm limited by there being 8y's. There are 8y's down here, so that's it. So 8y's and 8y's. So y to the 8th. In essence, whenever you have a variable to a power, it's always going to be your lowest exponential power will be that greatest common factor. So here you have 3 numbers this time. I'd like for you to pause the video and see if we get the same answers. Alright, so for this one, factors. This one's tricky because I have a -6 in there. So let's actually write out just for our coefficients, 12, -6, and 3. And I'll start with 3. I'll start with the smaller. So 1 and 3 and -6. Now this is where it's tricky because I can have a -1 and 6, or I can have 1 and a -6, and I can have 2 and a -2, and I can have a -3, 3. Here, let me rewrite this to write it more. In essence, in order to get In order to make a negative number, I have to have one of those factors be negative. So a negative 1 times 6 is a negative 6, or 1 times a negative 6 is a negative 6. I cannot say 1 times 6 is a negative 6. I cannot say a negative 1 times a negative 6 is negative 6. Do you understand? So that one's a little trickier. So there's all my factors, but I got to make sure they match up. And then I have 12. So 1, 2, 3, 4, 6, and 12. Well, what I'm limited by is 3. 3 is positive, positive. That is my greatest factors concerning my coefficients. So I know I have 3. And again, we'll go back to this problem. I'm limited by the exponent to the lowest power. So I have x cubed, x to the 4th, x to the 5th, x cubed. 3 x cubed. Whoops, man, that was crooked. Sorry. All right, so another example. We're going to factor out the greatest common factor. So here's my problem, or my example. I have 6y to the 4th plus 2y cubed. Well, 2 is my numeric greatest common factor, and y cubed is going to be my greatest common factor for my variable. So I'm going to factor that out, meaning I'm more or less going to divide both of these by 2y cubed right here. It's the opposite of the distributive property in many ways. I'm pulling out. That's what I've done. I've pulled out. So I can look at this and say 2y cubed times 3y is 6y to the 4th. 6y to the 4th. And 2y cubed times 1 is 2y cubed. More or less, I pulled those out. So what I would like for you to do are the next 3 examples. I would like for you to factor out the greatest common factor. All right, in this problem, I am going to have 4 as the factor that I can pull out. And more or less, it's like dividing. 4x divided by 4 is x. A negative 8y divided by 4 is a negative 2y. And 12 divided by 4 is 3. See, if I multiplied through, if I distributed that 4, I would end up with 4x minus 8y plus 12. And what I told you, it is more or less like this. I find that greatest common factor and I divide everything by that greatest common factor. And what I have left over is going to be inside the parentheses. What I was dividing by goes outside of the parentheses. All right, in this one, I have no coefficients, I only have variables, so I know my greatest common factor for my variables is going to be the one with the lowest exponential power. A cubed, b squared. This was a to the 7th, b to the 5th, a to the 3rd, b to the 2nd, a to the 4th, b to the 3rd. And I'll show it to you as a division problem. It's going to be like this. Exponential rules, or exponent rules, remember we subtract, so that becomes a to the 4th, b to the 3rd, minus 1, those cancel, and this one right here becomes a, b. Writing it in standard form, I would rewrite it like this. In this one here, I need to perform the distributive property first, or I could do something else. What do you notice that is the same? Yes, this will save me so much time doing this. This and this are the same. I'm going to factor those out. I'm going to pull those out. And whenever I pull out x squared plus 5, what am I left with? What remains? Well, here is a y, and here's a minus 3. And that's it. Again, it was just like saying, okay, my greatest common factor is this, the thing that's the same between all of them. They cancel, right? That's all you're left with. What you were dividing by, you write in front of the parentheses, and then you just, inside the parentheses, you write what's left. Okay, that's factoring out the greatest common factor. And now we're going to look at factoring by grouping. So, in our example, we're given x cubed plus 2x squared plus 5x plus 10. What I've done is, what I've written in red, I'm going to group together. And what I've written in blue, I'm going to group together. I look at what I can factor out here. I can factor out an x squared. Well, whenever I pull an x squared from this, I'm left with x. Whenever I pull an x squared from this, I'm left with 2. With this one, I can factor out a 5. Whenever I pull out a 5 from there, I'm left with an x plus 2. So what I do, this is now a common factor, x plus 2 and x plus 2. I'm going to factor those out. So there it is, I pulled it out, and what remains, x squared and 5, x squared and 5. That was factoring by grouping. I could also switch it up, and I could group other terms. See here, I said, okay, well, we'll say x cubed and 5x. So I wrote those next together using commutative property, and 2x squared and 10. And I wrote those next to each other. Now what can I factor out? I can factor out an x. So I pulled out an x, and that leaves x squared plus 5. And here I can factor out a 2. Factor out a 2, that leaves 2x squared plus 5. What's the same in here? X squared plus 5 is my common factor. If I factor those out, x squared plus 5, what remains? X and 2. X plus 2. And what would happen, you can easily check your work, is I can multiply, just like we do with multiplying polynomials, and once I multiply these two together, this is what I will end up with. Same here. This is just the commutative property of multiplication. See, I have x plus 2 times x squared plus 5. Here I have x squared plus 5 times x plus 2. Same thing. Same as saying 4 times 2 or 2 times 4. They both equal 8. So, pause the video and work these two problems, and let's see if we get the same answer. Alright, so what I'm going to do is that I am going to keep them like they are, and I'm going to do this one and this one. So for this one here, I can factor out a 5 from these two terms. So I pull out a 5, and that leaves me with an x here and a 3 here. See, and if I distributed at 5, that would give me 5x plus 15. Here, I can factor out a y. It's what I have in common between those two terms. So plus y, and that leaves x plus 3. This is what I want to see. I want to get to where I have the same term inside those parentheses. Now, since those are the same, I can factor these two out. I'm going to pull these out, and whenever I pull that out, what am I left with? Well, that's gone, and that's gone. I'm left with 5 plus y. 5 plus y. For this one, I'll leave them the same. I'll just factor them as they are. I can factor out a 2x squared. So if I pull out a 2x squared, that'll leave me with 3x plus 2. And here I'm going to factor out a negative 5. That leaves me with 3x plus or minus, right? Nope, plus 2. Think about it if you get confused. Look at it and say, okay, a negative 5 times, say a negative 2, it'd give me a plus 10. Nope, so I need to say a negative 5 plus 2 times a positive 2 will give me a negative 10. And look, I have 3x plus 2 and 3x plus 2. I can factor those two out, pull them out, so that gives me 3x plus 2 my pencil's lead is dying on me. And see, they're gone now. I've pulled them out, so what's left? 2x squared minus 5. 2x squared minus 5. Okay guys, that is your greatest common factor and factoring by grouping. Good luck on your homework.